Hi, this is Shoikat Mohinder. In basic physics course of Diploma Engineering, we will discuss wave theory of light and interference, which is in continuation of our previous video. This module falls under Unit 4 of light. Now, characteristics of light waves are: the velocity of light wave is not constant. It depends on the type of the medium the wave travels through. The velocity of speed of light in vacuum is denoted by c. c is equal to 3 into 10 to the power 8 meter per second. The relationship among the frequency f, velocity of light c, and wavelength lambda is expressed mathematically as lambda is equal to c by f. From the previous equation, it can be seen that wavelength lambda is inversely proportional to the frequency f. So, lambda is inversely proportional to the frequency f. So, higher the frequency, shorter the wavelength; lower the frequency, longer the wavelength. Light waves have different colors of dispersion, depends on the frequency f or wavelength lambda. Different frequency or wavelength of wave will give different color of light as shown in the table. Light wave could diffract and interfere as shown in. So, when the light is falling on the sharp edges, so spreading of plane waves, they pass through the hole. So this one is the wave crest, this one is the white one, blue one is the crest, white one is the wave trough. Now this is the diffraction, these are the wave front, this is the wave front. Now for interference, when light waves coming from these holes, they superimpose each other and they produce constructive interference and destructive interference. Constructive interference occurs where wave crests meet. Destructive interference occurs when wave crest and trough meets. The propagation of light through space can be described in terms of a traveling wave motion. The light wave moves energy without moving mass from one place to another at a speed independent of its intensity or wavelength. The light wave could move in three different polarization. Number 1, linear polarization. Number 2, circular polarization. Number 3, elliptical polarization. This is the figure of the light waves vibrating along this direction. This is the linear polarization. Again, light wave is due to the electric field vibrations. So when the electric field along this direction, this is the direction of vibration. Now, when the electric fields are moving, this is the direction when the intensity of these two axes are same, then it is a circularly polarized light. The wave while approaching an observer, its electric vector would appear to the rotating counterclockwise. This is called right circular polarization. When the intensities of y and z axis are different, suppose z axis is more, y axis is less, then it is elliptically polarized light. This wave, while approaching an observer, its electric vector would appear to be rotating counterclockwise. This is called right elliptic polarization. The main difference between the circular and elliptical polarization is intensities are different for elliptically polarized light. So the scientists Isaac Newton, who explained reflection, refraction phenomena of colors. Max Planck, with the help of quantum theory, explained black body radiation. Albert Einstein explained the quantum theory, explained photoelectric effect with the help of quantum theory. Isaac Newton in 1704 proposed that light consists of a stream of small particles because it travels in straight lines at great speeds, is reflected from mirrors in a predictable way. This is a steel ball falling here in the steel plate and reflecting back, rebounding this. So light like this one, like steel ball, it is falling here on the mirror and is reflecting back. The rebounding actually. So Newton observed that reflection of light from a mirror resembles the rebound of a steel ball from a steel plate. Particle theory explained that the particle photon as a nature of light. From quantum perspective, light consists of particles called photon. So what is photon? Photon is a very tiny little particle that has energy and movement, that is momentum, but it has no mass or electrical charge. According to Einstein, photon is considered as discrete packet of energy known as quantum. So photon is a very tiny small particle that couldn't see by eyes. Photon, its frequency is hf and momentum is hf by c. When the velocity of the photon is c. Characteristic of photon: the photon has no mass and electrical charge. Photon carries electromagnetic energy E and momentum P, as well as an intrinsic angular momentum or spin associated with its polarization properties. Photon travels at the speed of light in vacuum, that is equal to 3 into 10 to the power 8 meter per second. Characteristics of light photon. Photon has a wave-like character that determines the localization properties in space and time and the rules by which it interferes and diffracts. Photons are always in motion. Photons can produce infrared light, visible light, sunlight, that is sunlight, ultraviolet or UV light, UVA and UVB rays that give you sunburns, X-rays These are the photons. So already we have discussed photon, its energy is hf, it is equal to hc by lambda, its unit in joule. H is the Planck's constant, its value is 6.625 10 to the power minus 34 joule per second. C is the velocity of light, which is equal to 3 into 10 to the power 8 meter per second. Lambda is the wavelength of light. A photon also carries momentum, and it is represented by P. The momentum is related to the energy by P is equal to E by C is equal to H by lambda. So energy of the light photon, already we have discussed, is proportional to the frequency and inversely proportional to the wavelength. So higher the frequency, lower the wavelength. So higher the frequency means higher the energy of the photon. Higher the frequency, photon gains more energy. Lower the frequency means photon gains less energy. For example, blue ray has more energy than red ray because blue ray has higher frequency and shorter wavelength. Photons can interact with other particles such as electrons, protons, neutrons, etc. When photons bump into another atoms, some of their energy can get the electrons in those atoms moving faster than they were before. That's what we call heat. That's why you get hot sitting in the sun. A photoelectric experiment by Einstein shows that a very energetic photons of blue light has a very high frequency and low wavelength could knock the electrons out from the metal surface to produce a current shown in the figure here. So these are the light photon falling on the sodium metal plate. Electrons are ejected from the surface. This is the circuitry for this one. So we will discuss it in detail in the video lecture of photoelectric effect. The increasing of frequency will increase the energy of photon. Therefore, the photons of blue light could eject the electrons compared to red light because the blue light has higher frequency. So this is a range of frequencies of electromagnetic radiation, and it is known as electromagnetic spectrum. So here it is, the shortest wavelength, that means 10 to the minus 12 picometer to 10 to the minus 11 picometer, it is gamma rays. 10 to the minus 11 to 10 to the minus 8, that means 10 picometer to 10 nanometer, it is a range of X-rays. When the wavelength is in between 10 nanometer to 100 nanometer, it is far ultraviolet wave. And 10 to the power minus 7 meter, that means 100 nanometer, it is in the range of near ultraviolet, and visible range is 400 nanometer to 700 nanometer. It is a visible range of light. And 1 micrometer to 10 micrometer near infrared, from this part frequency of 10 to the power 13 Hz to 12, then it is far infrared, and this is the microwave, radar, TV, FM, AM/OF. These are the wavelengths. These are the visible spectrum, 350 to 800 nanometer. Visible light is a small part of the energy range of electromagnetic waves. The whole range is called electromagnetic spectrum, and visible light is in the middle of it. So light coming from sun to the earth, these are visible light, ultraviolet light and infrared radiations. So these are the electromagnetic spectrum. So middle of this is the visible light. More than the wavelength, more than the frequency, these are the ultraviolet, X-rays and gamma rays. When the frequencies are less, heat lamps, cooking lasers, radar, etc. So low energy, these are the radar, radio, cooking cell phones, heat lamps, TV remote. High energy means ultraviolet, X-ray, gamma rays, etc. So low energy means low frequency, means long wavelength. High energy means high frequency, means short wavelength. So higher the frequency of the light, the higher the energy of the wave. Since the color is related to the frequency and wavelength, there is also a direct relation between color and energy. So red color, its wavelength is less, its wavelength is long, high, so its frequency is less, its energy is also less. So wavelength is 650 nanometers, frequency is 462 terahertz. Violet light, its wavelength is shortest, 400 nanometer, its frequency is highest, 750 terahertz. This is the spectrum of the visible light. So color of lights we can get, if white light is made to fall on a prism or glass prism, then light is spreading out. Red, orange, yellow, green, blue, indigo and violet, 7 colors. This is known as Vizier. We see the colors in rainbow also. So red, its energy is less, violet, its energy is maximum. So from red to violet, its energy will increase. From violet to red, wavelength will decrease. From red to violet, its frequency will increase. By definition, visible light is a special kind of electromagnetic energy with a wavelength range from 380 nanometer to 740 nanometer. This electromagnetic energy consists two components, which are electric field E and magnetic field H, which oscillate and perpendicular to each other. This electromagnetic radiation are produced by the vibrations of a charged particles called photons. So we know that light travels in a straight line. The experimental setup is like this. There is a candle, the cardboards, there are holes, and these holes A, B, C are in straight line. If our eye is here, then we can see the light from this point. If our eye moves, then we cannot see the light. If the candle is moved again, or the alignment of the cardboards are changed, then we cannot see the light from this position. So this is the example that light moves in straight line. This straight line is called ray of light. Light travels at a high speed. The speed of light in vacuum is 3 into 10 to the power 8 meter per second. We know light travels in vacuum in constant speed. However, the light travels in non-vacuum media such as air, glass, water. The speed of light will decrease. In air, it is 0.03% slower. In glass, it is 30+% slower than the vacuum. A bundle of rays is called beam of light. The beam of light may be parallel, this is parallel, may be converging or may be diverging. So we know the light has different colors. Light has no mass but carries energy and momentum. So if the frequency is increasing, the energy of the light will also increase. Frequency decreases, energy of light decreases. Light is emitted and is absorbed in the form of quanta but propagated in the form of waves. So this is a different phenomenon of light when it interacts with other objects such as, so this is a glass surface. So when light is passing, this is passed through. When it is reflected, this is reflection of light. When it is scattered, this is scattering of light. When the light is absorbed, it is absorption of light. When it is refracted, this is refraction of light. This is the refraction. That means angle is changing. When there is no change in angle, there is pass through. The different sources of light are natural sources, sun, star, radio star, lightning, or any body that exists at a temperature over absolute zero. Man-made source, incandescent light, fluorescent light, heater, lasers, antennas, radars, X-ray tubes, etc. All materials with temperature above absolute zero emit electromagnetic radiation light. For example, atoms and molecules which has their own characteristics set as spectral lines. In this case, we are studying two theories of light. One is atomic equilibrium, another one is black body radiation.